a graph of? F prime. So if this is a graph of F prime, can I just look for where it's increasing? No. I need to look for where it's what? Above the x-axis. If I want F to be increasing, then F prime of x needs to be positive. For F to be increasing, F prime has to be positive, which I think somebody said it has to be above. That's perfect. So look at your graph. When is it above the x-axis? -2 till 1, and then again till 3. So it'd be answer choice B. Now, could they break it up and put a union? Sure, but they don't have to. You don't have to, but they probably won't. Okay, come down to part B. Says, using the same graph above, where does F have a point of inflection? So we have to go back to think about it. If I want F to have a point of inflection, do I care about F prime or F double prime? F double prime. And what is that in the graph of F prime? A slope. Very good. So I need F double prime to change sign, which is the slope of F prime to change sign. Okay, so that should be kind of like how you think about it, is point of inflection, second derivative. If this is F prime, F double prime is the slope. Okay, so put x's on the graph where you have points of inflection. You should find 4 of them. Okay, where do I put my first x? -1, then where? Then 4. All of those are POIs. Very good. So I'd say x equals -1, 1, 2, and 4. Now, real quick on the graph, I want you to label the relative extrema and then label what kind it is. There's only one. Okay, remember that your critical numbers are your x-intercepts. I'm at the x-axis here, 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 and here. But which one of them does it pass through the x-axis? At 3, which way is it? A max. Very good. Okay, so that is a relative max right there. Max is positive to negative, because think about the slope, right? Max is positive slope, negative slope. Okay? Now, what would you classify the other 3 as? Neithers. Very good, because F prime doesn't change sign. It doesn't pass through the x-axis, okay? Last part, part C. List where F is increasing at an increasing rate. Okay, what is the first derivative if I want F to be increasing? Okay, positive or above the x-axis. Good. And then if I want it to be done at an increasing rate, what's my second derivative? Also positive. Which means what characteristic am I looking for in the graph? A positive slope. Okay? So then look at your graph. Where is it both of those things? Above, and it has a positive slope. 2 places. -2 to 1 and 1 to 2. Very good. -2 to -1, union 1 to 2. Okay? Now, fast forward down to me to number 2, part C. Number 2, part C. It says, where would the speed be increasing? How do you know when speed is increasing? They don't have to both be positive, they just have to match. So they can both be positive or both be negative. And so several of y'all missed that on your test. So if you want to, I'm not going to do this one, but your V of t and A of t need to have the same sign. So you should be looking for places where it's above with a positive slope or below with a negative slope. Okay? Go ahead and turn the page, please. Okay? So you should know how to do graphs of F, F prime, and F double prime. Look at number 3. Okay, I'll do this one with you. It says F has the property that f of x f prime of x and f double prime are all negative for all real values of x. So let's go through what each of those things means. If, maybe down here, if f of x is negative, what does that mean about my graph? It has to always be where? Below the x-axis. So look at your graphs. Which one is not always below the x-axis? E is out. Okay, now let's talk about f prime. If f prime of x is negative, what does that tell me about f? It has to always be what? Has to have a negative slope. Very good. Because remember, what's f prime? It's the slope of the graph. So look at your graphs. Which one has a positive slope? For any part of the graph. C has a positive slope. Where else? A. This part has a positive slope. That's not allowed. Okay, so positive slope. Can't be that one. Okay, then what does my second derivative tell me? Concave what? Down. So out of your two remaining graphs, which one is not always concave down? D. Look at this little piece. That part counts as concave up. So that would not be allowed. Concave up. So it would have to be B. Okay? Alright, turn the page. Sure. I'm going to send out a key though later. So, okay, next one that we're going to do is number 7. Now, notice for first and second derivative test, if you want f to be decreasing or f to be increasing, which test is that? First or second derivative? First. First derivative test. First derivative test. Now, when you take the derivatives for both of those, what rule are you going to need? Product rule and product rule. Okay, product rule on both. Now, actually, somebody said quotient rule. If that's an e to the negative x, could you put the e on the bottom and turn it into a quotient rule? Sure, if you want to. That's probably harder, but you could. Okay? I'm going to come down to number 7 and do that one with you. Okay, look at number 7. It says f is a function for all real numbers. F prime equals 4 minus x squared over x minus 2. F is decreasing on the interval. Okay, is that first or second derivative test? First derivative test. Now, specifically, what sign do I want for the first derivative? Negative. Now, the first step is to take the derivative. Do I need to take the derivative here? Why not? They already gave you f prime. So I'm going to rewrite my f prime of x equals, okay, it's 4 minus x squared over x minus 2. Next, I need to identify my critical number. So I get to kind of skip that step because they already took the derivative. Okay, how can I factor the top of that? Okay, now don't switch the order. You have to go in order. What's the first square root? 2. So it'd be 2 plus x and 2 minus x. Now, because of the absolute value bars, if you switch the order, it actually wouldn't make a difference, but if those bars weren't there, that would not be correct. Okay, so make sure you don't want to switch the order around unless you pull a negative out. Okay, then on the bottom I have an x minus 2. What are... Negative x squared plus 4? You could, but you'd have to take the negative out and then do x plus or minus 2. Does that make sense? Okay. So from there, what are my critical numbers? 2 and negative 2. Now, where do those numbers come from? The top or the bottom? Either one. It doesn't matter. Okay? So, set up your line test. We're going to go all the way to the infinities because it's not particle motion. You're not looking at time or anything. Okay? And then when I plug stuff in, do I really have to check the top? Why not? If these are absolute value bars, what's the sign? It's always positive. And if it's always positive, I'm going to just kind of ignore it. So let's say I plug in 3 over here on the right side. What's 3 minus 2? Okay, positive 1. In the middle, I'm going to plug in 0. What's 0 minus 2? Negative. And then if I pick maybe negative 3, Negative 3 minus 2 is negative. So these are the signs of f prime. They tell us what f is doing. What was f doing? Decreasing, decreasing, increasing. So where is my graph decreasing? Which answer is going to be right? A. Good. Okay, makes sense? Alright, number 8's very similar to that. I want you to give it a shot. So it says g is differentiable. G of x is always less than 0. For all real numbers x, f prime equals blah, blah, blah. Which of the following is true? Are you going to take the derivative? No. They already did it for you. All you need to do is the line test. What are my critical numbers? Okay, negative 3 and 2, yeah. You don't need a positive 3 because that's not going to make that 0. Now, let's talk about g of x. Is g of x ever going to equal 0? How do you know? That's correct. Look what it says right here. What is g of x? Always less than 0, so it doesn't ever give you 0. So we only have 2. Set up your number line. Okay, I want you to check the sign of this interval first. So the far right. What are you plugging in? Okay, 3 sounds good. What's 3 minus 2? Positive. What's anything squared? So is it positive? What's g of x? Less than 0 means it's negative. So this term is always positive, but this term is always negative, because they told you it's less than 0. So if it's a positive times a positive times a negative, that makes that interval negative, yeah? Okay, now do the other two, and then pick your answer. But remember, your g of x is always negative, because it had told you that. Sure. Okay, so I plugged in 3 was my test point. So I did 3 minus 2 is positive. Okay, that squared is positive. And then when I get to g of x, I don't know what g is, but they told me right here that it's always what? Less than 0. So that means that if it's negative, I had a positive times a positive times a negative. That means it's negative. So you don't know what g is, but you know that its sign is always less than 0. Okay, so then my other two are both going to be plus, right? Is that what you got? Now, how do I know that there's no sign change at negative 3? Because that term was what? Squared. And remember, if it's squared or fourth power or absolute value, there will be no sign change. So, which one do I want? Is there a correct answer there? Yeah, A. Yep, good. Thanks. Okay, turn the page. Next one, we'll do 9. Okay, it says to find extrema. What does extrema refer to? Min or max is very good. Now, some of you didn't know how to start this on your test, and I just cried inside. What do you do first? Okay, so 3x squared minus what? 18x minus 21. I get no point because I didn't what? Label it. F prime of x equals. Okay, then after I take the derivative and I label it, what am I setting it equal to? If you don't put the 0, a lot of y'all missed like a whole letter grade on your test for that. Okay, after you take the derivative, you set it equal to 0. What can I take out? So it'd be x squared minus 6x minus 7. What will multiply to negative 7 and add to negative 6? It'd have to be minus 7 and plus 1, yeah? So my critical numbers are going to be 7 and negative 1. Set up your line chart. Remember, if it's time, you're going to cut it off. But if it's not, you're looking at the whole number line. If you're solving by factoring, it has to be equal to 0. That's the only way that you can factor. Okay? So then from there, I'm going to plug in 8 first. 8 plus 1 is positive. 8 minus 7 is positive. Overall positive. Do I know I'm going to have a sign change at 7? Yes, so it has to turn negative. Do I know I'm going to have a sign change at negative 1? Yes, it has to go back to positive. And remember, how do I know that? Because it's not squared. It's not to a 4th power. It's not inside absolute value bars. So it's going to go up, down, up, which means that x equals negative 1 is a max, 7 is a min. Okay, look at the next one. It says locate all extrema for the function on the interval, means that you're doing a candidates test. If they give you an interval, you should be setting up a candidates chart. Correct. So x f of x. My endpoints are negative 2 and 0. Which of my critical numbers will not make the chart? 7, because why? It's outside. Okay? Now, you do not have a calculator for your test tomorrow. So, let's practice without. If I plug in 0, remember I'm plugging into the original. Okay, yeah, let's do 0 first. 0 is going to be the easiest. So it'd be 0 minus 0 minus 0 plus 3 is 3. Okay, now let's plug in negative 2. Ready? So we're plugging in right here. So it'd be negative 2 cubed minus 9 times negative 2 squared minus 21 times negative 2 plus 3. What is negative 2 cubed? Okay, here, can I cross these negatives out? No. What's negative 2 squared? 4. So that doesn't get to keep its negative to cross out with anybody. So this is a minus 36. Okay, then here, minus a negative, that's going to turn into a plus 42 plus 3. And then this is how I do it. I'm going to add my negatives together and my positives together. So that's a negative 44. That's a plus 45. Overall, it gives me 1. Okay, you do it for negative 1 while I go wake some people up. I want to. I can't wait to do it.
Leave me alone.
Johnny. Hey, I got here early for you today.
Yeah, I was moving, so I forgot.
Okay, well, I was crying at my desk uselessly that I woke up early and you didn't even come.
What time?
I mean, like 6:45.
No, that's when you woke up?
Yes. But also I made Ashton cinnamon rolls, so that was also a factor.
Did you give me some?
Maybe I would have if you'd showed up, but... What'd you get? Isn't it 12 or 14 or something? Should be 14. Okay, so this would be a negative 1. This turns into a minus 9. That turns into a plus 21 and then a plus 3. Then if you combine the negative guys, that's a negative 10. That's a 24. 24 minus 10 is 14. Which answer is right? A, B, C, or D? Which one? Good, D. This is the max. This is the min. So I know it has to be D. Okay? Last part says F is concave down when? Concavity is what kind of test? Good. Concavity is a second derivative test. What do I do first? Well, I already have the first derivative, so take the second derivative. Okay, which would be what? I'm taking it from here, so I don't have to do product rule. Minus. Then I do what? Okay, factor it. So I put a 6 on the outside. What's left over? Ooh, I've missed a point. Yes. Okay, then what's my PPOI, my possible point of inflection? It'd be 3, right? Set up your number line. 3 is the only guy on there. If I plug in 0, 0 minus 3 is negative, other side is positive. That means concave down, then concave up. So where's my graph concave down? Which interval? less than 3, which is, do you see it on there? See? Get it? F prime and F. You're right. Gotta label it. Now, the good news is that your CBA tomorrow is multiple choice, so I'm not going to be checking for justifies or labeled stuff, but you should still practice it. No, not tomorrow. Tomorrow will be just only Scantron. Okay, come down to number 11. How do you do the equation of a tangent line? Okay, you need a point and a slope. Now look, they gave you some crap. Which one's the point? F of 2, good. F of 2 is the point. What does that make my point? 2, 8. Okay, which of those gives me the slope? Okay, this is the slope, and it's 3. Then from there, what's the equation of my tangent line? Y minus 3x minus 2. Yep. Yeah, and then some of y'all love to solve. Just don't. You waste time for no reason. Okay, leave it like that. Okay, part B. Will your tangent line be greater than or less than the values of f? How do I know if it's greater than or less than? What feature of the graph? The only other crap they gave you, concavity. Remember, concavity is what tells you that. Now, if f double prime at 2 is 5, that tells me the concavity, what is it? Up or down if the second derivative is 5. Positive 5 tells me it's concave up. So I'm going to put then, bless you, f is concave up around where? X equals 2. So tangent line is, okay, let's draw a graph. Concave up. Where will my tangent line fall? Below. So tangent line is below or less than values. Okay? Great. Turn the page. Okay, your next topic is implicit differentiation. Y'all sound so happy to be. Do you need a cookie or candy? Okay, fine. Oh, too slow. Okay, come on. Got it? Okay, real quick, I need you to fix number 12. You're finding the values of y in part C, and then these should all be y's. Y. Okay, but I'm not going to do that one with you. I'm going to do 13 with you. So I'd like for you to take the derivative. I'm going to come bring you a motivational treat. 13. You are going to have to use product rule in the middle. Very good. So right here, when you get to this part, you're going to have to do product rule. Now, question, should you be putting dx dt's on stuff? No, that's for the word problem-y stuff. So if it's an x, you take the normal derivative. If it's a y, you put a dy dx on the end. Yeah? Remember that? Okay, and then product rule in the middle. So you can do it. And then if you can get part A, you should be able to get at least start part B. How are you pooping and now you're your plus y when it moved over should have turned into a minus y. And so then, if they're both negatives on the top, the answer choices, they factor the negative out to the front. And it's the same answer as yours. You're welcome. I am, except that your 3y squared needs a dy dx on it. And erase the dy dx equals. So then you have to put equals and then the other side. What's the derivative of 0 on the other side? Yes.
When you went after the one.
I would put it on the other side, yeah. Keep it in the same order. So like this is all your x crap with dy dx's and then equals 0. And then remember next, Colton, you're going to have to move your non-dy dx terms over to the other side. If you get part A, try part B. Yeah, if you want a horizontal tangent, you're setting the top equal to 0. What about if you want an undefined slope? You'd be setting the bottom equal to 0. I'll just get what everybody gets back. That's very sweet. Did you do product rule on the xy? Did you do product rule on that? Got one? Got one of these? Well, hold on, your product rule isn't going to be the x squared. You'll take the derivative of the x squared first, and then your product rule will be the xy in the middle. Hey, look, you're not going to be sleepy anymore. Where you going? Okay, what answer is correct? It is A. Now, if you got this, negative 2x minus y over x plus 3y squared, okay, these are the same. What's the only difference? They took the negative out. Now, you don't have to do that, but when you're trying to match your answer, you need to think about those are equal to each other, so A is correct. Okay, go down to part B. And when I send out the key, I will show the steps for this, but that one's not really super hard, so you should be able to mostly get it. Okay, part B, I want a horizontal tangent. That means that I want the slope to be what if it's horizontal? That means that I'm going to set the top equal to 0. Now, you can use the top with the negatives or the top without the negatives. It doesn't matter, they're the same. So, do we want to do with the negatives or without? Sounds good, without. Okay, so 2x plus y equals 0. I know I'm going to have to do a substitution because I don't just have one letter, I have two. So, what would y be equal to if I solved? Negative 2x, good. And that'll be my substitution. Where am I going to substitute? The original, very good. You are going to substitute into the original. So come back to the original here. I have x squared plus xy plus y cubed, and I'm subbing in y equals negative 2x. So here we go. X squared plus x times y is a negative 2x. Y is a negative 2x cubed equals 0. Okay, what would I do first? I want to combine some like terms. So if this is an x times a negative 2x, that's a what? Negative 2x squared. Okay, and then on this next one, remember you have to cube both. So it's not going to stay at 2, it's going to turn into a what? 2 times 2 times 2. 8. Okay, what do I do from there? Come on, like terms. These guys can go together. What is 1x squared minus 2x squared? Negative 1x squared minus 8x cubed equals 0. Okay, from here you should solve by factoring, but it's not like a trinomial, it's a GCF. I can't take out a 2 because that's a 1, but I can take out an x squared. Yeah?
That's what I meant.
Oh, okay. So negative 1 is going to come out, and then x squared is going to come out. What's left over? I have to leave a placeholder here. So I leave a 1 plus or minus on the 8 if I took the negative out. Plus 8x equals 0. And then from there, if I have an x in the front, what's my first answer? 0. So this one, or this one. So D is out. And then from there, if I let, some of y'all can do it in your head, but if I let that equal 0, I would get what as my answer? Negative 1 over 8, which would be B. So I would have to subtract the 1 across and then divide by 8, yeah? Okay. So it'd be negative 1 over 8. All right, turn the page. The last topic on your CBA is related rates. We're going to do 15. Set up your find given when for me, please. Yes? You may. Sure. Okay, it says the volume's increasing at a rate of 20. How fast in square centimeters per second is the surface area increasing at the instant when the edge is 10? Now, they gave you how many formulas? 2. So you're probably going to end up using both at some point. So what did they give me? Rate of what? The volume is increasing at a rate of 20. So dV dt is 20. How fast is the surface area increasing? What would I put for that? That's my find. Now, you could put ds dt. I'm going to use dA dt just because it's area. But you could use ds dt and it wouldn't really matter. Okay, now let's start with our area formula. How do I find the area? Wait, what's my when? The edge is 10, so x is 10. Okay, what is area? It's up there for you. Yep, 6x squared, and then I'm going to take the derivative. So what's the derivative of a? What would that be called? dA dt. What's the derivative of 6x squared? 12x what? dx dt. Very good. Now, when I get to here, I want dA dt. I know x. Do I know dx dt? No, you're going to have to do a little side problem. So I get to here, I'm going to go ahead and put dA dt equals 12 times 10, but then I don't know dx dt. I'm going to have to go back and find it. And how do you guess we're going to find it? Volume, right? If they gave me dV dt, I'm going to have to use that to find dx dt. So volume is x cubed. Well, then what is dV dt? On the other side, it'd be 3x squared what? dx dt. And then what is dV dt as my substitute? So 20. 3 times my side length, my edge is what? 10 squared, right? Didn't they say the edge is 10? And then dx dt here. What is 100, or what is 10 squared? Times 3? So it'd be 20 over 300. Yeah? And then what do I do with that? Yeah, plug that back into the original. Hello? I do have Mark. Okay, thank you. Bye. Mark, you're done too. Thank you. Okay, so I'm plugging in 20 over 300. Now, this is what I would do. Okay, what is 100 times 20? That'd be 200, yeah? And if that's over 300, do y'all remember if you cross out the same number of zeros on the top and the bottom, it's allowed? So if I do 200 over 300, that's really just 2 over 3. And then everybody can do 12 times 2 over 3. What's 12 times 2 on top? 24. Divide by 3 is 8. Answer choice A. Okay? Okay, now, number 16. Okay? Listen. The one on your CBA is a ladder problem. So I picked this one because it looks kind of like a ladder problem. Okay, but it turns out to be freaking hard. So I'm going to do it for you, but I don't want you to lose confidence in yourself because the one on the CBA is not this hard. I just kind of picked it like, oh, a ladder, perfect. But when you actually do it, it's a little bit harder. But I want to walk you through it because if you want to get a 5, you're going to have to get some of these right. Not all of them, okay, but some of them. Okay, so eat your candy or your cookie. Okay, and know that the one tomorrow is not this hard. It's like a normal ladder like you have in your notes. Okay, so are we ready? Yes, we're ready. Okay, find given when. Okay, I'm going to squeeze it in here. Okay, it says in the figure above, PQ represents a 40-foot ladder, okay, with end P against the wall, Q level on the ground. If the ladder is slipping down the wall, okay, this part looks familiar, okay, what is the distance RQ at the instant when Q is moving along the ground 3/4 as fast as P is moving down the wall? It gets a little weird. Okay, what are we finding? What is the distance RQ? Are they asking for a rate this time? No, they're asking for the side. Now, to keep things simple, I'm going to call this side P, I'm going to call this side Q, so that I don't have to call it RP and then RQ, because that's kind of too much. So, which side am I looking for if I want leg RQ? Q. So, I'm looking for the side Q, not the derivative. How long that side is. Okay, so far so good? Okay, now we're going to dissect this sentence right here. It says Q is moving along the ground 3/4 as fast as P is moving down the wall. Instead of giving you the rate, they're telling you the relationship. What would I call how fast Q is moving? dq dt. And how is it related to how fast P is moving? It's 3/4 of dp dt. So far so good? Okay, now we're going to set up our equation. Notice they didn't give you a when, so I'm just going to scribble that out. There's no when. Okay, my equation is Pythagorean theorem. So it'd be P squared plus Q squared equals 40 squared. Take the derivative. What's the derivative of P squared? 2P dp dt. What's the derivative of Q squared? 2Q dq dt. And then what's the derivative of 40 squared? 0, because it's a what? Constant. So the derivative of a constant is always 0. Okay, now we're going to plug in the only thing that we know. What do we know about dq dt? 3/4 dp dt. So I have 2p dp dt, 2q, and then when I get to dq dt, I'm plugging in 3/4 dp dt. Yeah? Any questions so far? Okay, then I look at it and I'm like, well, crap, I don't know P, I don't know Q. Which one am I supposed to be finding? Q. So we're going to handle that in a second. Let's simplify this first. So it's 2p dp dt. And then I'm going to take this term to the other side. What is 2 times 3 on top? 6/4, but now it's a negative 6/4. So I have 6/4, but now it's negative on the other side. Now, why would I want to separate those? What do both of them have? A dp dt. And if they both have a dp dt, then can I cancel it out? Yeah, because I'm going to divide by dp dt on both sides, right? And now they're gone. So now my equation looks a lot neater. So I have 2p equals negative 6 over 4q. Okay, now let's solve for q the rest of the way. So I know that my negative 6 over 4, I can multiply by negative 4 over 6. And what am I going to get for my fraction then? Q is what? On top, I'd have 4 times 2 is 8 over 6 p. Yeah? Okay, what do we do when we need to get rid of a letter? Go back to the original and do a what? Substitution. So, come back to right here, and I want you to solve it for p. Okay, it's not going to be hard. What's going to happen with the q squared? Other side. So now I have p squared equals 40 squared is 1600. You could use a calculator on that. Minus q squared. And then what would I have to do after that? To get p all the way by itself. Square root. Now, some of you love to make up your own rule and say that that's 40 minus q. That's not a thing. Don't do that. Okay, you're like, oh, square root. Not a thing. Don't do that. Okay, so I'm now going to take this. I'm going to plug it in right here. So far, so good? So it's negative 8 over 6. And then I have 1600 minus q squared. All of that should be under the square root. Okay, my q is under a square root. How do I undo a square root? Square both sides. So I'm going to square here, and I'm going to square here. Now, when I square the q, it's just a q squared. We're almost done. We're getting there, okay? Sorry this is so hard, but it's so fun, right, to do. Okay, look at how smart your brain is. Okay, now, when I square a fraction, I have to square both parts. So 8 on top is how many? 64. 6 on bottom is 36. And now what magicalness happens here? Now it's just a 1600 minus q squared. Okay, we're going to distribute now. Look, I have a calculator. You don't even have to get yours out. Okay, 64 over 36 times 1600 is, what? It's that. Math, enter. We'll fraction it up. What? What do you mean it's not a fraction? Math, enter. Okay, we'll just make it q squared equals 16 over 9 times 1600 minus 16 over 9 q squared. Okay, now we got to get our q squareds on the same side. Look at them. They're apart from each other. They want to be together. So how do I get rid of minus 16 over 9 q squared? Add it over to the other side. And if this is a 9 over 9 q squared, because it's like one whole one, what is 9 over 9 plus my 16 that's moving over? 25 over 9 q squared. This is so great. Okay, and then what do we do next? We're almost done. Oh wait, that's, yeah, it was from when we did, oh, I simplified this in the calculator.
Oh.
Calc, and I simplified. Okay, then how do I get rid of this? Flip it and then square root. It's 32, yay! Okay, you can do it. Huh? You what?
I zoned out after you said DQ.
Wow, boo.
I'm not gonna be here tomorrow or Friday.
Oh, okay. You still have to take your CBA, but it's going to be a lot harder after Thanksgiving break when you forget everything.
Yeah.